Hello students, welcome to another session of Gyanon lectures powered by Wishback Technology, and today we will learn about minimum shift keying or MSK. We can say it is a form of frequency modulation based on a system known as continuous phase shift keying or CPFSK. It offers advantages in terms of spectral efficiency compared to other similar modes. Let's talk about the need of MSK. And additionally, it enables power amplifiers to operate in saturation, enabling them to provide high levels of efficiency. We know that the binary data consists of sharp transitions and potentially creates signals that have sidebands stretching out a long way from the carrier. And this creates problem for many radio communication systems, as any sidebands outside the allowed bandwidth can cause interference to adjacent channels. Minimum shift keying has the feature that here are no phase discontinuities and the significantly diminished the bandwidth required over the form of phase and frequency shift keying. The peak frequency difference is equal to 1/4 of the bit rate. MSK has the modulation index of 0.5. Now let's talk about the working operation of MSK. The name minimum shift keying implies the minimum frequency separation that allows orthogonal detection as two FSK signals, that is VHT and VLT. Now the equation becomes integration of 0 to t VHT multiplied by VLT dt, that is equals to 0. MSK is a spectrally efficient modulation system and it is particularly engaged for use in mobile communication systems because of its possesses properties such as constant envelope, spectral efficiency, good BER performance, and self-synchronizing capability. Now MSK changes in phase to represent zeros and ones, but unlike most other keying and the pulse sent to represent 0 or a 1 not only depends on what information is being sent but what was previously sent. The pulse used in MSK is the following. S of t is root under 2 EB by TB multiplied by cos of 2 pi FCT plus theta t, where theta t is equal to theta of 0 plus pi h by TB if 1 is sent, and theta of t is equal to theta of 0 minus pi h by TB if 0 is sent. Now from the equation we can see that theta t depends not only on the symbol being sent, but it can be seen that also depends on theta 0. This means that the pulse depends on what was previously sent. Let's work through an example. Assume the data being sent is 111010000 and the phase fluctuation of the signal is displayed. An MSK signal can be considered as a spectral form of OQPSK, where baseband rectangular pulses are restored with half sinusoidal pulses. The block schematic diagram of an MSK modulator is displayed. However, this cannot be easily converted to hardware as an exact relation between the symbol rate and modulation index that is required necessary to integrate control circuitry. An advantage of this structure is that it can be used for both analog and digital input signals. Now talking about demodulation of MSK signal, an MSK modulated signal can be demodulated by either a coherent or differential non-coherent demodulation technique. The coherent demodulation system needs a precise reference of a carrier, phase, and frequency for optimal demodulation. Hence, suboptimal differential modulated technique along with the threshold detection is a popular choice in many applications such as in cellular telephony. Now we have compared MSK to QPSK, and the derivation of MSK is presented by analyzing the changes in phase. MSK is a form of frequency shift keying with Fc that is equal to half multiplied by F1 plus F2 and H that is equals to TB multiplied by F1 minus F2, where F1 and F2 are the frequencies used for the pulses. MSK creates an FSK with minimum difference between the frequencies of the two FSK signals such that the signals do not conflict with each other. MSK offers a power spectral density that falls off much faster related to the spectrum of QPSK, while QPSK fall off at the inverse square of the frequency. MSK falls off at the inverse fourth power of the frequency. Thus, MSK can operate in a smaller bandwidth compared to QPSK. Now, with this, we have come to an end of this lecture, and today we have learned introduction to minimum shift keying, need and requirement of MSK, working operation of MSK, MSK modulator, demodulation of MSK signal, and MSK compared to QPSK. We will continue our discussion on MSK in our next videos and about its application and fundamentals also. Till then, keep watching and keep learning.